All right, here's the basic picture for number 1 through 4, right? So let's go through it and explain it just a little bit. Let's put a few extra things in here. Put some lines here. This is a line right there. This is a capital A down here. This is a capital B up here. So this is plane B. This is plane A. This point right here is point R and S down here. On this line is TUV. So put a point T right here, a point U here, and a point V here. Then they have a little lowercase letter. Remember, we could name this line right here several different ways. You could name it with capital letters with points on the line, or you could name it with a little lowercase letter, just one letter right here. And then you got some points over here. This is X, this is Y, and this is Z. I think we covered everything, didn't we? Yep. All right, so let's see what they're asking about this. So number 1 says, name another line, or what is another name for line M? So if you're looking at this line right here, this is line M, but we want another name for it. Now you can name it several different things. This is what I will not accept, okay? And this is what a lot of people did. A lot of people put TUV. Do we name a line with 3 points? With 2 points. We name a line with only 2 points, not with 3. Alright, so we use 2 points. You can use any of the 2 points that are on this line, and it doesn't matter what order you put them in. Alright, and it is a line, so you should put the little line symbol over it. So you could just say TU if you wanted to, and that would be it. That's all you need to do. Is that the only answer? No, there's other ones. You could say, what else? What would be another answer to this? Say it. UV, right. You could say line UV. What would another one be? TV. Or you could go backwards on it, right? You could go UT and VU and VT. You can go any of those possibilities, all right? It doesn't have to be just this, but those are all your possibilities. The thing that not a lot, but several people did, was they put line TUV. That's not it, all right? You can't use 3 points to name a line. You use 3 points to name an angle, but you can't use 3 points to name a line. Everybody understand that? Okay, so that would be one possible answer for number 1. Let's take a look at number 2. It says name 3 points on plane B. I think most people got this. Where's plane B? Plane B is this one right here. In fact, let's just we'll just change the color of this to, I don't know, yellow. And I could probably fill it in. Let's see. I haven't tried this before. Let's try that. Oh, look at that. That's pretty bright, isn't it? I think I can change the... Let's see, if I change the opacity, does that make it lighter? I know what it's doing there. I don't know, I'm just playing around, sorry. I think there's a way you can change like how bright it is. There should be. Not sure how to do that though. But that's okay, we'll just say that. That's pretty bright. But you get the idea. Tell you what, maybe there's like a lighter color. Maybe that's what I can do. How about like that? Yeah, it looks a little better. Alright, this plane right here, that's plane B. It says name 3 points on plane B. So, let's go back to this again. Alright. Just name 3 points. It doesn't have to be T, U, and V, but you could. Alright, so now if it says name 3 points, you're not really, you're not putting them all together. You're not finding a line or anything like that. You're just listing 3 points. So if I just list 3 points, just put a comma in between the points like this. Alright, so that would be one possible answer, but there are a couple other points on this plane. What are some other points? R and S, right? So it doesn't matter which ones you pick. You could pick T, U, V, R, and S. Any of those 3. It says name 3 points on there. You can pick any of those 3. You don't have to pick T, U, and V, but you could have picked R and you could have picked S as well. Any combination of the 3. Don't put all 5 of them down. Alright, just any combination of those 3 points. Doesn't matter what order they're in or anything else. Everybody understand that? Yeah, pretty easy. Number 3 says name the intersections of plane A and B. This is the hardest one out of this these 4 questions right here. It says name the intersection of the 2 planes. Well, if you take a look, let's see if I can try this again. We'll go with a different color right here. Look at the 2 planes, the 2 colored planes right there. Where do they intersect each other? At a line, don't they? They intersect at a line. If I put 2 pieces of paper together, not flat, but like, you know, edge to edge, what is formed when I put those 2 things together? You have a line that's formed between them. So our answer is a line. Let me go back to this. Okay, so our answer is line RS. And so you put a line symbol over top of it, R and S. You can put SR if you want to. It doesn't make any difference. Same thing. But that's what it is. It's a line. So two planes intersect at a line. All right? Number 4. This is the last one with this picture. It says name 3 non-collinear. I'm going to write that word down. It's supposed to be an N. Non-collinear. Well, collinear means what do? The lines do what? They lie on the same line, don't they? So if it's non-collinear, we're talking about 3 points that what? That don't lie on the same line. So basically, you can use any of the points on these planes right here except for what? What's the only thing that you could not use? The 3 points you could not use? T, U, and V. That's right. You could use X, Y, and Z. You could use X, T, and S. You could use Z, R, and V. You could use any 3 points except for T, U, and V. Why is that? Because they lie on the same line. That's right. Everybody understand? You could use R and S as long as you use one of the points that's not on line RS. So I could say RS and X, couldn't I? Or RSZ or RST. As long as the 3 points don't all lie on the same line, then that's what you can use. Does it make sense? So you got a lot of different possibilities here. The only thing that you can't do is T, U, and V. Does that make sense to everybody? All right. So enough of that. That should have been pretty easy, I think. Let's move on to ones that are a little bit more difficult. All right, and look at number 5. It says find the length of line segment LO. So we're trying to find, that's not, kind of looks like an angle symbol, doesn't it? Try to make it look at L. O, it's kind of ugly. All right, so we're trying to find the length of line segment LO if O is between L and M. Now watch. When I'm just looking at this, if I just look at this problem, I really want to visualize it. I want to see it in front of me. So let's draw a line, and let's put on this line what they tell me. It says O is between L and M. So if L is right here and M is right here, it says O is between them. Does that mean it has to be right dead in the middle? No, it doesn't have to be in the middle. It could be anywhere. It could be like right here. Okay, it could have been right here. As long as L is on one side as M's on the other side, then O is between them. Everybody got that? All right, so it says find the length of LO if O is between L and M, and then they tell you a couple of things. They tell you that LM is equal to 18.6, and they also tell you that OM is equal to 12.9. All right, so what do? I got a little picture here, so guess what I'm going to do? I'm going to put those in the picture. So let's take a look. They tell you LM. They tell you that whole entire thing, don't they? If you can't draw that fancy thing, just put the number up here. However you want to do that. So that whole thing is 18.6. And OM is this part of it right here. That part right there is 12.9. And what are we trying to find? We're trying to find LO from here to here. Let's do this in a different color. So what we're trying to find is from here to there. Everybody with me on that? So what do? They give you the whole thing, and then give you this part of it. You got to figure out what's left over. What math do we do to figure out what's left over? You subtract. That's all there is to it. All right. So look, the math is not difficult. It's knowing what to do. It's knowing that you're supposed to subtract it to find out what's left over. Some people added those together. All right. You don't add them together because 18.6 is that whole entire thing. They told you the whole thing. They told you this part of it. You got to figure out what's left over. If you figure out what's left over, that tells you that you subtract to get what's left over. Okay, and that's a let's see, that's that, and that's a 7, isn't it? Yeah. So that's a 7, and we borrowed from here, and that's a 5, so it's 5.7. So LO is equal to 5.7. All right. That's all you do. Just subtract those two numbers. But again, you have to know to subtract them. I could do this on the test. I don't know. I don't have the midterm memorized or anything. But they might tell you LO and they might tell you OM. And they might ask for LM. What would you do to those two numbers? Would you subtract to get that? No, what would you do? Add them up. That's right. So if they told you LO and OM, you'd add them up. So I think it's a lot easier to draw this picture out It lets you visualize what's going on instead of just reading the problem right from the test and trying to figure out, oh, do I add, do I subtract, what do I do? So I would draw them out like this. We okay? All right, let's move on. Number 6. This one's similar to what we just did right there, but they draw the picture for you. That's kind of nice of them. And what do they tell you? D, E, and F. So they put a D right here, put an E about right in here, and the endpoint here is F. And they tell you the whole thing. This is how they show this. They put a little, well, they do this, they do this. They say 24, and they put a little arrow like that. That means the whole entire thing, right? DF. If you wanted to draw that cool looking brace looking thing, if you want to do that, that's fine as well. But then they tell you they put a 3x plus 5 right here, and they put a 5x minus 13 right here. It's been a while since I graded these, but somehow I remember grading these, and a lot of people just set these equal to each other and solve for x. All right, it's not what we're trying to do. We're trying to find the length of DE, which means we do have to find x. Okay, we're trying to find the length of line segment DE. We're trying to find this length from here to here. But we got to do something first before we find that length, don't we? I can't just take this away from 24, can I? Or this away from 24, because I don't know what this is. So I have to find what x is. And again, I remember this. A lot of people made this mistake by setting them equal to each other and solving for x and plugging that in. All right? Are these two segments necessarily equal to each other? Did we say that E is the midpoint? No, not at all. All right? Never said that in here. But what do these two segments do? What does this segment from here to here and from here to here do to make 24? I heard it. They add up. They add up to be 24. Again, the math is not all that difficult. It's knowing what to do. What math are you supposed to do? Are you supposed to subtract? You're supposed to set them equal? You're supposed to add them up? What do they equal if I add them up? That's the geometry. So this segment plus this segment right here equals the whole entire thing. And that's what you have to know. That's the geometry. So 3x plus 5 and then the 5x minus 13, that has to equal the whole entire thing, which is 24. And now you just do your math. You solve for x, you plug it back in. Let's do that very quickly here. So that's going to be 8x. That's a minus 8. If I add an 8, that's what? 32, right? Divide by 8, and x is 4. Is that my answer? Do I circle it? No, because what are they asking me to find? Line segment DE. Now you had to find x. Don't get me wrong. You had to find what x is, but that's not my answer, though. Yeah, you're finding DE, so just plug it into here. So take that x equals 4, plug it in right there. Because that's what we're trying to find, isn't it? DE. So I plug it in for this x, and I figure out what it is. So it's 3 times x, 3 times 4, plus 5. That's 12 plus 5 is 17. So DE is equal to 17. And that's your answer. So you had to do a couple steps here. About 3 steps, didn't you? You had to know, you had to set it up first. Then you had to solve for x, and then you had to plug it in. So that's basically 3 steps right there. Does that make sense? It's not that hard now that you look at it. We've done a lot of that kind of stuff since then. But this is one of the early times that we did this kind of thing, where we had to add things up, set them equal to something, or we had to set things equal. And back then, it was a little more confusing. We've had a lot more practice with this kind of stuff since then, so hopefully, looking back on it, it looks a little bit easier now than it did back then. Anybody feel that way?
Yeah.
Okay? Okay. So let's do another. Number 7. It says a square has a length of 3.7. Now, if you get confused on this, what would you draw? A square, absolutely. Now, you may not have to do this on this problem. This problem wasn't really all that difficult. But if you need to, go ahead and draw what they tell you to. It says a square has a side length of 3.7 feet. So one of these sides is 3.7. The question says, what is the area? Area equals question mark. All right, what is the area? Well, first of all, how do we find the area of this thing? We have a little formula. Do you remember that? What's the area of a rectangle or a square? It's the length times the width. All right, that's a real basic formula that everybody should know. All right, that the area of a square is length times width. So if this is 3.7, what's this up top here? It's also 3.7. So how do I find the area of this thing? Just multiply them together. 3.7 times 3.7. All right, and get whatever you get. Okay, let's just do it right here. 3.7 times 3.7. And there you go, 13.69. Or if you wanted to, you could have done what? 3.7 squared. That's right. It's the same thing, isn't it? Might be a little easier. Same exact answer, isn't it? Yep, 13.69. 13.69. If you wanted to round it to 13.7, I would have given you that as well. But if you have a decimal, at least keep it one decimal place. All right, don't round it to 14. All right, keep it at least. I would just put 0.69 since it stops right there and it doesn't keep repeating or anything. I would just keep it 13.69. Yes. I'm not going to mark off. I mean, there are teachers that will mark off if you don't do that. This is feet, right? Yeah. This is in feet. So technically, you're right. It should be 15 feet squared. A lot of teachers will mark off for that. They're very, very picky about that. At my other school, I taught physics, and we used units all the time in physics, and I would take off a point if they missed the unit or they didn't put it on there. But I'm just trying to teach you the math right now. But you're right, and I don't blame the teacher if they do take off points for that, but I just don't do that. Okay? Let's see. Let's use that color. We're rolling right along. Number 8. Distance. Now, I told you I'd give you this formula, but just because I give you the formula doesn't mean you're going to get the answer right. You got to know how to use the formula. So I will give you this formula, the distance formula. Here it is. It's a square root. Kind of looks like Pythagorean theorem because that's where we got it from. All right, so I start off like this. This is kind of like the shell of my little formula right here. And now I'm going to plug some stuff in. So we just subtract the x's, put them in one parentheses. We subtract the y's, put them in another parentheses. And it doesn't matter. A lot of kids say, Mr. Hamrick, the book says x2 minus x1. It'll be the same exact thing. You'll get the same exact answer. As long as you subtract the x's, you subtract the y's, put them in this formula, and you're good to go. So let's take a look at number 8. It says find the distance. Find the distance. Now the next problem will say find the midpoint. And the problems kind of look exactly the same. They just give you two ordered pairs, but you're asking for something completely different. Finding the distance, you're finding how far it is between this point and this point. You're actually finding the length of that line right there. That's what you're doing. You find the distance. The midpoint, you're actually finding a point that's halfway in between. So they're two completely different answers, and I still get people that, after we talked about it over and over again, that for like midpoint, they use the distance formula, and for distance formula, they use the midpoint. Know which one does what. All right, so this is distance, and let's see the points they give you. They give you point L is -5, -1, and they give you point M, and that's 2, 4. All right, so let's do this very quickly. Ready? Let's find the distance. So distance equals big old square root. I put the shell of the formula. Right? That's like the outside of it. And now I'll put all the stuff in. I'll plug everything in. Now this says we subtract the x's from each other. So don't subtract -5 and -1 from each other. Subtract the x's from each other. So these two are my x's. Hope you're getting this. -5 minus 2. And now subtract the y's from each other. The second part of my ordered pair are the y's. So I subtract them from each other. So it's -1 minus 4. I got a lot of crazy things here. I saw some people set it up right, but then I don't understand where you're getting some of the numbers that go into this. Take the x's and subtract them. Take the y's and subtract them. And then you just work the thing out. -5 minus 2 is -7. But it's being squared. And then -1 minus 4 is -5. And that's being squared. If you can't do that in your head, use a calculator for goodness sakes, okay? I mean, it'd be really nice if you could do this in your head and not have to use a calculator, but if it comes to taking a quiz or a test and you still aren't sure about how to add and subtract these things, use a calculator for goodness sakes. Get the right answer. So here we go. Square root. -7 squared. I'm squaring the negative as well, and it's going to be a positive 49. I'm also squaring the -5 right here, and I'm adding them together. That's going to be a positive 25. Okay, add them together, and that's a 4, and that's a 7, right? So it's the square root of 74, and you're done. I'm not even going to make you simplify this if it does simplify. Okay, I don't think this one does, but just keep it the square root of whatever. Don't put it into a calculator and get a decimal answer. All right, just keep it like that and you're good to go. It's not so hard, is it? Especially if I give you the formula. All right, if I give you the formula, there's no excuse not to get this. Okay, it's just knowing what to put into the formula. All right. All right. Should be able to finish. That was number 8. I only got 2 more to do, right? Number 9. It says find the midpoints. All right, so midpoint. Let's write down the formula for midpoint. The midpoint, MP, equals. Now it's a point, so it's an ordered pair. It's not just a number. It's not just, one number. It's an ordered pair. It's a point on the graph. And it's midpoint, so we take half, don't we? So make sure you always take half. Now, what do I do to my x's this time? On the distance formula, I subtracted the x's. What do I do on the midpoint? I add them. That's right. All right, so I add the x's and I divide by 2 because we're finding the halfway point. That's why I divide by 2. And then I do the same thing with the y's. It's an ordered pair, isn't it? It's not just a one-number answer like the square root of 74 was a one-number answer. This is actually a point on the graph. Now you should know this, but if you don't, I'll give you a formula sheet and it'll be on there. But you need to know how to use it though. All right, so number 9, let's put the 2 points on there that they give you. They say that point M is 2, 4, and point N is 5, -3. You don't have to graph this or anything. I've seen people try to graph this. Okay, you don't need to graph it. You've got the formula right there. So let's find it. So the midpoint is, it's an ordered pair. Put it over 2, put it over 2. And then we just add the x's together. So a midpoint, you add the x's. Remember that long story you had about the McDonald's and finding the distance between and then finding the halfway point, right, on our little trip? So make sure you remember that. So 2 plus 5, I'm going to put it right there. So I took the x's and I added them together. Then I take the y's and I add them together. 4 plus -3, or just 4 minus 3. Now we just work this out. 2 plus 5 is 7 over 2. 4 minus 3 is 1 over 2. And that's your answer right there. You don't need to change it. You don't need to make it a decimal. You don't have to put that into a mixed number. Just keep it like that. That's the answer that I want to see right there. Now, if you would have changed it to a mixed number, that's 7 over 2, or a decimal, that'd be okay. I mean, I'll give it to you. It doesn't mean it's wrong, but you don't need to go through that. I'm trying to save you some steps. All right? All right. Number 10 is a little more complicated. We gave like a little shortcut, I guess you could say. Screen. But let me just start from scratch, because sometimes we don't remember the shortcut, but we do know the formula. Okay, I gave you the formula. Now watch what they tell you. It says find the coordinates of point Q. It says find them. That means I don't know them, right? So I don't know what that is right there. So I'll make one x and I'll make one y because I don't know what that coordinate is. It says they tell you point P, which is 3, 2. And they tell you that point P is the midpoint of NQ. So watch. We've got NQ, line segment NQ. P is actually the midpoint of this line segment. So if I got Q and I know the midpoint, they need to tell me what N is as well, don't they? And they do. Just 5, -3. See what they're doing? So it's like this. You don't have to draw this right here, but just to kind of get a visualization of what's going on. Look, there's actually, it's not straight up and down, but let's just do this just to visualize what's happening. So what did they do? There's one endpoint, there's another endpoint, and where is P? P is the what? It's the midpoint, so it's got to be the halfway point, right? So that would be P. You follow me? All right. So look what they give you. They give you a midpoint this time. On that other problem we did, they didn't give you the midpoint. You had to find the midpoint. But this time they actually give you the midpoint. And they give you one of the endpoints right here. So they give you one endpoint. We got to find the other endpoint. So let's put it into the midpoint formula. Let's write it down one more time. It's quick and easy to write. So we'll just write it down so we can see what's going on. All right, so there's our midpoint formula just so we can see it. So let's put some stuff in here. Now remember what this was. This thing right here was the what? We said it already a couple times. That's the midpoint, isn't it? So look what we're going to do. We're going to take this and put it in for midpoint. I'm going to do some other colors. We don't get too green here. So watch what I do. I know what the midpoint is. So I'm going to put in 3, 2 for the midpoint. Everybody with me on that? Now let's do this part of it. This x1 and x2 are my endpoints, aren't they? It's the x to one endpoint, and it's the x to the other endpoint. Problem is, I don't know what that endpoint is, but I do know that one. So what do I do with those two x's, according to my formula? I add them up, right? So it's going to be x plus 5 divided by 2. Hope you guys are watching. A lot of you guys are tuned out, I can tell. And whoever's clicking back there, please need to stop. I thought you might stop on your own, but I had to say something. Look right here. Hilarious. You guys are cracking me up. So look at this. This is y plus -3 or -3. I could just shut this down and not even go over these at all. I could just work on the next test, I guess. So let's take a look. So I set it up. I threw everything into my formula. This is where it gets a little bit tricky, but it's not that bad. Look, this is the first part of my ordered pair. This is the first part of my ordered pair. So this has to equal this right here. X plus 5 over 2 has to equal 3. So let's set that up. X plus 5 over 2 has to equal 3. And we can do some work and solve for x. Same thing over here. Watch. Y minus 3 over 2. That has to equal, what do you think? Equals 2. And we're running out of time, but you can do the work on this. I'll do one of these. Multiply both sides by 2. Multiply that side by 2. So I've got x plus 5 equals 6. Subtract 5 from both sides, and x equals 1. We'll do this one. Multiply both sides by 2. Y minus 3 equals 4. Add a 3 to both sides, and y is 7. So my question is, what is that point? What is that missing point? You have to write it as a point. So it's going to be 1, 7. 7. We just found it to be 7. All right? And that was number 10 right there. Look at that. Perfect timing. So I'm going to do 11 to 20 in the 5th period class. It's going to be your responsibility to look at that video